but it's basically a model that has learned to understand the context of words within a sentence and then generate those sentences. So if you think of a word in a sentence, it can change depending on what you need. So what you're thinking of. So language itself, if you're talking about language and you are in an English class, you're talking about English, the language. But if you're talking about language in programming, you're talking about a programming language, and they're slightly different. So the context depends on where you're using it. So if a model can understand that context, and then it can use a base of information, like a library of books, and it can then be given a question, understand that question and the context within the question, it can then generate further information from that question. So you can say, the question is, what is a large language model? And it will use its whole amount of information stored in numbers in this giant model to generate an answer that is most closely related to the context within that question. That's essentially what it is. At its core, it's just generating words that match a certain prompt. And that's essentially what it is without all the dirty technical details.
So I mean, something that's quite interesting there, which I've been doing a bit of reading on, is also how important it is to be specific in your prompt. Because of that context, right? I know that in some courses that are being set up around AI now, that initial sort of introductory lectures on how to write prompts. Because if you are not writing in a particular way, then the context is not understood, and therefore the output is not necessarily what you want, which is an interesting kind of thought pattern. So answer then understanding the large language models. What was your next step in the research process?
So the next step is, once I know what it is, how do I actually use it? How do I tackle and use this thing? And the easiest way to use them is ChatGPT. Because then you just type in your prompt and you get a response back. So then I just start I had been playing around with ChatGPT for some time, but then I started playing around with ChatGPT and immersing myself in the world of prompting. So as we said, prompting is that idea of giving it an instruction, but making sure the instruction meets very closely what you want to get out. So you could very easily ask an actuarial or finance-related question and get a very finance-related answer, but it won't be an actuarial answer. But if you prompt it in an actuarial sense, you'll get an actuarial answer. So the first step was then, okay, at the very basic level, the easiest way to use this model is through ChatGPT. What are some good ways to interact with the model to get the output that I need as an actuary? And that was the discussion of the indirect assistant. Using ChatGPT and putting in the prompt. And then you can relate that to any area of your actuarial work. If you are building an Excel spreadsheet or you're writing a program for a certain task, you go to that website, you type in your prompt, you make sure your prompt is structured in a way that you'll get the answer out that you need, and then just apply it to your work. And you rinse and repeat in that manner to get the output that you want.
So I remember in the paper that you presented a number of sort of use cases that you had then tested as part of this process. Could you maybe just choose one and kind of unpack how you went about testing that use case?
So one interesting one is the regulatory knowledge base. So it's often in the actual world, if you're dealing a lot with capital calculations, you deal a lot with SAM. So solvency assessment and management. And you often have, so SAM itself was like 300 pages. And you often have these questions, and it's very difficult to then go into the text, search for your answer, pull it out, and then apply the answer. So it would be great to have some system that you could ask a question, and it will do all the searching for you, and it will bring out the information that you need, and you can then take that summarized information and generate your answer for yourself. So that was the one use case, is how can we use large language models to make the work of querying all this regulatory knowledge easier for the actuary. And that involved basically, the first question is, okay, we have the regulatory information here and we have a large language model somewhere else. How do we combine the two? And then the question then is, well, what is out there? Have people done this before? And people have done it before. They've built databases that store text information in a format that a large language model can query and understand. So then the answer is, take that information, put it into the database and link it to the large language model, and then question it. So that's the initial point. I get to the point where I have the database, I have the knowledge loaded up, And then you start playing around and testing. Does it actually answer the question you need? And also comparing it to, well, if I didn't link it to the database, could I just ask it directly and see? So is there even a point to creating this database and testing it? So in the paper as well, I compare a plain prompt without connecting to the database and the database prompt. And you can see that with the database prompt, it actually becomes a model that's tailored to the SAM documentation. So it will give you the answers, but then the quality of the answers is always up to question. And it will come down to prompting and few-shot learning and teaching the model how to give you the answer you need. But the step is that you've gotten to a point that you can extract the information more efficiently than you would have been able to do yourself. So what would have taken an hour, you've now brought down to a few minutes. And that's immediately a use case that actuaries can benefit from.
And in testing these use cases, did you ever come across a use case where you were like, it's actually not helpful, or it's actually maybe detrimental to the actuarial function that you were trying to test?
I think most use cases can straddle that line. I think if you don't construct the system well enough, you can very easily fall into the trap that you've made something that just does the job badly. So the knowledge base, for example, it gives you the answers that you then have to interpret. But if you blindly take the answers and apply it, then it's not going to be good. Because you then rely on the fact that the model is formulating the answer in a way that applies to your specific problem that the model has no view of.
So like a bit of confidence almost in that output.
Exactly, but if you spend more time developing the system, putting in guardrails and putting in information that will allow the knowledge base to craft the answer in a way that you can take the information out and then apply it to your problem in a more structured way, then you're moving into the space where it's more beneficial. So I think large language models can always be useful, but the question lies in, should we rely on them? And should we use them for certain tasks? And how much should we rely on them? Because at the end of the day, they are still mathematical models. And with any model, you shouldn't blindly trust the output. The problem with large language models is that they are so convincing that it seems like you're talking to a human that knows what they're doing. So it's much easier, I think, to blindly rely on it and then do the wrong thing.
Which I think is a particular danger for inexperienced, maybe like an actuarial analyst who hasn't necessarily got to the stage where they are as proficient as they need to be in order to understand those outputs. But I think another thing I would like to ask, and possibly there's an element of repetition here, but what other limitations would you highlight about using large language models? I mean, you've talked about just using it blindly, etc. But were there other sort of hurdles or glitches that you came across in sort of mastering and understanding the space?
So large language models themselves have a lot of limitations. One of them is called hallucination. So they'll essentially just generate rubbish. So you can ask it a question, and I almost view it as the large language models are so eager to please that they'll lie and they'll try to do whatever they can to make you happy. So you'll ask a question and they'll convincingly give you a great answer. But if you look deeper, you realize it just made things up. And this is famous in the law and research and academic areas because people have done that. They've asked for research papers to query or as references, and they've asked for legal results as references, and the models made it up. And they've put that into publication. And after the fact, they've been caught out and said, well, these papers don't actually exist. How did you get them? Well, I asked ChatGPT and it made something up. And it doesn't have a lot with code as well. So you can give it a coding problem, it will give you a great solution, and you run it and it'll just be nonsense. Because it's just
how does that actually happen though? Because it's not always hallucinating, right? It's very often, more often than not, and I think increasingly so, giving really good answers, right, depending on your part. But how does that hallucination come about?
At the core of what the model is, going back to what the large language model is, it's just generating text. So if it sees a question, it'll generate text that is as close to the solution, the actual answer as possible. If that actual answer exists out in the real world, then it brings that real answer in and gives you the solution you need. If it doesn't exist, it's still going to generate, but it's going to just pick things and say, well, this makes the most sense, so I'm going to generate that, whether it exists or not. So in the areas where it's going to struggle and it doesn't know the answer and the answer is not so clear, it's just going to make things up because that's what it's designed to do. It will generate things, which you can look as a bit of a bonus as well, because you can ask it a question that no one's asked before and see what it generates, and that will lead you down a road to where you might find a solution for yourself.
So, and I think, there is a kind of underlying, I don't know if it's fear necessarily, but concern, I think, from actuarial students who are aspiring to be actuaries, that AI will replace them. And, I think, and many things that you have said have kind of alluded to the need for oversight. But how would you say AI will play a role, or already does play a role in the actuarial industry, but also how it changes or is likely to change the role of the actuary going forward?
Yeah, the famous question, will it take my job?
Yeah, exactly.
I don't think it'll take our jobs. I think actuaries must give themselves more credit. I think a lot of professions need to give themselves more credit. The gap from a model to a human being is vastly larger than we appreciate or that we think it is. But that just demonstrates how convincing these models are. So I would say they wouldn't take our jobs, but they will drastically change elements of our job. So if you think back to early actuaries that used their tables and books, and they used slide rules, and they did all this calculation manually, and it meant they sat in a room for weeks on end doing calculations. When computers and Excel came along, it didn't take their job away. It just meant instead of them sitting for weeks in a room doing a calculation, they sat for a day on a computer doing a calculation. So in future, certain aspects of our job, for example, maybe looking up at the regulations or doing a certain calculation or writing some code, instead of us sitting for weeks writing the code, we will prompt a model to get the result, and we'll get much quicker to our answer, which means our role will go further into the space where we are challenging our solutions and ensuring that they are appropriate for the problem at hand. So we'll bring a lot more of the human and business element into actuaries' work and rely less on the technical side. But again, it does depend on the role. If you're an actuary that's very much so in that space already, it's not going to change your job a lot. You'll probably bring it in some areas. If you're an actuary that wants to be more technical or wants to program, it's just going to make your life easier, because now you have this tool that can help you get to that point. I think in a lot of other industries, there's talk that people will no longer program and only large language models will program. So they're saying, well, it's going to replace software developers. And again, I don't agree that it will replace them. I think it will just change how they do their work. So instead of the software developer designing and writing the program, they'll use this other tool to do that. But at the end of the day, there's still a person sitting and using the tool. I doubt in the near future, or even at any point, we'll get to a time where these models can just run completely unmonitored to do work, and humans can just sit and do nothing. I really doubt that eventuality.
But so given that answer, if you were chatting to an actuarial student who is interested in getting involved in the machine learning AI space, and that's not necessarily a formalized part of our studies as of yet, how would you suggest they go about that? I mean, you obviously said you were on YouTube, etc. Would you suggest they do that? Or would you suggest that they go and do a course? How would you suggest they kind of upskill themselves in that space, given that they aren't doing projects the way that you were at work, that there isn't necessarily that necessity given their studies? How would you kind of advise them then?
So I get this question a lot as well, and my answer is always the simple short answer is pick a project and dive in. If it's at work, that's a lot easier because you have more time to focus on it because your work is paying you to do it. But if it's not, then it's after your work, after your studies, in that very small amount of time that you have to yourself, you pick a project, you just dive in and do it. So for example, say you want to build a website that calculates a life annuity. You go online and you say, how do you build a website? And then you read about all the resources on how to build a website. That will lead you down different paths. It might lead you to a YouTube channel. It might lead you to a textbook. It might lead you to a guide. And you pick the one that suits your personality. For me, it was YouTube videos and sometimes textbooks. Other people might enjoy a course. They might need an instructor to lead this.
Depending on how they learn.
Depending on how they learn. So then they'll go for the course. They'll learn that, and then they'll apply what they learn to their project.